In episode 13 of the Junior PenTester training series, we go through the introduction of the cross-site scripting vulnerability and attack combination. And cross-site scripting has to do with the scripts that are embedded into the contents of a web page, and how you would go ahead then manipulate the various elements of a web page to do something that you would want it to do. And this would be a client-side attack. In the last video, we did server-side request forgery. That was a server-side attack. So this is something that happens through your web browser, and ideally it would submit obviously the request to the web server for it to process, and it requires both of those things to be misconfigured. So the client side as well as the server side both need to be misconfigured in order for this to work, and we're going to go through what that actually is and what you can do with that. There's the brief of the room, what XSS payloads are. There's something called reflected XSS, stored XSS, and then DOM-based XSS, and we'll go through all of those. And then there's something also called blind XSS that, as the name kind of implies, you don't get to see the responses from the web page, and you kind of have to try to find other ways to track whether or not your attack was successful. And then, of course, the various practical exercises that we have at the end of this, which is perfecting the payload that we have, and practical example for blind XSS. So these two actually have two completely separate virtual machines that we're going to end up using and attacking, and hopefully successfully manipulating and getting some results from them. And that'll be it for this specific video. Created through TryHackMe. We don't get the name of the developers for this room, although I know there was at some point there was a human being that sat down and did this, but sometimes they do give us the names of the developers, sometimes they don't. So just a shout out to TryHackMe. This is a subscriber only room, so it means you do need a paid subscription in order to be able to access the virtual machines. But for the content, you can, it's all free for you because I'm going to go through it right now. I get nothing from TryHackMe to promote them, but I think they're a really, really amazing platform, and a lot of universities use them because it gives you a controlled environment to run hacking exercises, and you won't get into any kind of trouble. So you get attack boxes, you get virtual machines that will be your targets and your victim machines, so on and so forth. Really, really great platform. So if you don't have a membership, I encourage you to check it out. If not, you can get a free membership. They have, I think, 300 or 400 rooms that are available for free through just a basic membership, and you can go ahead and get access to that as well. And even those rooms have virtual machines and attack boxes that you can use. So that being said, a quick word from our sponsor, Hackaholics Anonymous, and then we're going to dive into it. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the introduction to cross-site scripting. As a quick heads up, since we're going to be talking about scripting, cross-site scripting, right? So it's all based on JavaScript. So it would be useful if you knew what JavaScript was, or at least had a basic understanding of that language. We are going to go through some examples of it, and I'll do my best to explain it so that if you don't have a background in JavaScript, you'll still understand what's going on. And there's also going to be client-server requests that we're going to be submitting, so understanding what that means, what requests in general mean, and what responses mean, and what types of responses we can expect based on the requests that we submit. It's a very basic understanding of just HTTP and web application interactions and website interactions, all of those things, super, super basic understanding. So ideally, it would be useful for you to have an understanding of both of those concepts, which is JavaScript as well as client-server requests and responses. Cross-site scripting, also known as XSS in the SysAdmin community, is classified as an injection attack, where malicious JavaScript gets injected into a web application with the intention of being executed by other users. And in this room, we're going to learn about these different types of attacks, how to actually create the payloads, how to modify the payloads to evade filters, and of course, end up with a practical lab where we can try it out and see what we can get done. These vulnerabilities are extremely common. There are a few reports of these things found in massive applications, and we can get paid very well to find them. So one of the big things in the CySec community and the pen testing community is called a bug bounty. And I've done just a few shorts on YouTube just to kind of demonstrate what some of the biggest bug bounties in the world will pay you. But Apple has a $2 million bug bounty program where if you can actually find some bugs in their applications or in their services, you'll get paid really, really big money. But then there's a bunch of different websites, for example, Shopify or Steam Chat or HackerOne, and all of these things that actually pay you real good money. HackerOne is a marketplace for different companies to come to and hire individual contractors like freelance hackers, and then you'll get paid to go ahead and hack into these different companies and try to find whatever their vulnerabilities are. So in this example, they found a stored XSS vulnerability via the assets, but it's been blocked by the CSP. So an asset like this right here, go to the program, etc., 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 was the first step, right? And then the next one was to go to the created program, then create the asset, submit a report. Whenever the asset is rendering, the XSS is firing, and open the submitted report, and it's still going to be firing, and then click edit, and it's still be firing. The impact would be that it's executing for anybody and everybody that would be using it, and this was one of those things that ended up paying this particular person, right? I think, what was the dollar amount? It said $2,500 to find that specific vulnerability. And it's not $2 million that you would get paid from Apple, but $2,500 is not a bad chunk of money, or getting $7,500 for something that was found in Steam Chat, which is another one of those things that was through HackerOne. So HackerOne is one of these locations where it's a marketplace. It's a giant marketplace of companies, for example, Tinder or Dynatrace or InDrive, or a bunch of companies that are available that are looking for people to hack them, and you can get paid anywhere from $1,000 to $100,000. So these are not small bug bounties. There are some small ones, right? So this is like a $50 one. This is a $99 one. So there are some small bug bounties, but you can get paid to practice your hacking skills. That's kind of the concept here, right? So if you just want to practice and you want a real environment to practice without getting penalized or without getting any kind of a issue, you can always come to HackerOne, choose Wells Fargo, for example, read through the rules for their the bug bounty program that they have, and then from there you can implement various attacks to see if you can get past some of their defenses or find any glitches in their systems, and then they'll pay you. So this is probably the best way that I can have anybody who's interested in becoming a hacker practice their skills without getting into any kind of trouble. And that would be to actually go to a place that they'll pay you to do it. So that is that for the introduction. So what does XSS stand for? It stands for cross-site scripting. So let's talk about the various payloads. A payload is the JavaScript code that we want to be executed on the actual target's computer. So there are two parts to this. There's the intention of the payload and the modification of the payload. The intention is what you want the JavaScript to actually do, and we're going to talk about it in future pieces in this video. The modification is the changes to the code that we have to make to execute every scenario, because every scenario is different, right? So again, we're going to be talking about that in a little bit. So these are some examples, right? So this is the simplest that can actually happen, and it basically is going to pop up a box. It's like a little pop-up box that comes up on the screen that just says alert. That's basically it. It's just like a little script that executes, and the pop-up it doesn't say alert. It's an alert pop-up, and then it'll say XSS on the screen. That would be what's going to be inside of the alert pop-up box, right? This is just a proof of concept to see whether or not the website is actually even vulnerable to an XSS attack, right? So this would be like the very first thing. It doesn't do anything malicious. It's just a pop-up that comes onto the screen. It reads XSS, and if you see it, and if it executes successfully, that means that that specific part of that website is vulnerable to these types of attacks. Session stealing is one of the really big ones. So if you want to get the login tokens, for example, of a website's or of a user's session on a website, these things are kept in cookies on their machine. So it would be on the user's machine inside of their web browser. So this specific script right here takes the target's cookie, it base64 encodes the cookie to ensure that we can actually transmit it across to us, and then post it to a website that is controlled by the hacker. And once that has the hacker actually has these cookies, they can take over the target session and be logged in as that person. And this is all done through this it's a relatively simple script, right? So it'll fetch from the hacker steal cookie. So this is what it's going to fetch, this specific piece right here. And then it's going to take the document cookie, which is from the person, and it's going to ideally transfer it. We can also just go ahead and get like a real detailed explanation of this instead of me butchering the explanation of this. So let's see what we can get from our favorite Google AI right here. So it says this is a simple script that attempts to steal cookies from a user's browser. Script and script are the beginning and end of this. The fetch portion is a modern JavaScript API used for making network requests like fetching resources. This specific portion is the base URL to which the stolen cookie will be sent. And so it just tells it to us right here. It just breaks it for us, right? So this is the root, the domain controlled by the attacker. The steal is the path on the attacker server, like a script or something. And then the cookie parameter is the following data will be a query parameter named cookie. And then we concatenate it, that plus sign that you see at the end right here. Where is it? This piece right here. So this piece, this whole piece is combined, concatenated, meaning this piece right here will be added to the end of this, right? So the cookie is going to equal whatever the value of this is going to end up being. And so that gets concatenated to this. Now, the document cookie is the property that accesses all the cookies that belong to a current domain that the user is visiting. And these are typically used for session management, user preferences, etc. The BTOA part is a function that encodes a string in base64. And it's often used to make binary data, safe for transmission, etc. That's it, right? So very, very simple, right? So how this works is that if there's a vulnerable website that actually has this kind of a vulnerability, they can inject this specific JavaScript into a page on this website, right? This element, this script tag going into example.com through some kind of a field that would allow us to do it, like a comment field or a profile page or anything that actually has an input, and that input was not sanitized. So we have to input it somewhere. And so when you inject this into something, it could literally be something that would be injected into here, into Gemini right here, right? This is technically an input field, this piece at the bottom of the screen right here. But when I did it, Gemini actually read it, and instead of fetching my cookies on this website, it starts giving me an explanation. So you know that there's like a really advanced filtering and sanitization process on Google Gemini, but technically any portion of a website that you can print something or type something into, it's technically a location that you can submit some kind of JavaScript code, and then based on what its functions are, it would do it for you. So this specific one steals session cookies. This one right here is a keylogger. So it acts as a keylogger. It means that anything you type on the web page will be forwarded to a website under the hacker's control. So this will capture your usernames and your passwords or any kind of commands or things like that. So if you want to be installed on the acceptor user login or credit card details, things like that, that could actually be captured. So document on key press. This is one of these JavaScript functions that are available, and then it's going to execute and then of course fetch this piece, and then it's going to concatenate it with a base64 encoding of whatever that key is, and that'll be sent to whatever that website is, the hacker's website right here, right? Business logic. So this is a lot more specific than everything else, and it would be about calling a particular network resource or JavaScript function. So imagine a function for changing the user's email address that's called user change email, and your payload would do that. So it would say user change email, and then it would change it to the attacker's email. But this specific piece right here is calling on a function that already exists in JavaScript that we're now calling upon, and that function does a bunch of other things in the background. So it looks really simple right here, because this is what it's supposed to kind of look like. You wouldn't type up the whole function's code. You would just reference the function and then say change it to this specific value, and this function is going to work in the background and it's going to do what it needs to do to change the email of that current user to the email address of the hacker, and then the hacker would then presumably be able to log into the guy's, let's say, bank account by using his own email, or he could change the user's password by using his own email. And then once he's changed the password and it's his own email, it's really crazy when you really think about it. So it's very, very powerful stuff. These things are very, very powerful tactics, and they're not things that don't exist in the world anymore. None of these things that we're talking about are expired and don't exist. These things actually really do exist, and you can actually use them. You would just have to go through the motions to be able to find them. And a great playing ground for that would be a place like HackerOne, and finding any of those vendors and then just kind of running through these exercises. So which document property could contain the user's session token, and that would be the document cookie property. Which JavaScript method is often used as a proof of concept, and that is the alert that we just saw at the very, very beginning. So now that we have that, let's talk about the different types of XSS vulnerabilities or attacks that we could execute. Reflected XSS happens when user supplied data in an HTTP request is included in the web page source without any validation. Okay, so here's the example. A website, if you enter incorrect input, an error message is displayed. So the content of the error message gets taken from the error parameter in the query string, and it's built directly into the page source. So this would be the query string that we see right here, and you have the error parameter invalid output detected. Okay, and if you look at the source code, you can see that there's an alert that says invalid input detected, right? So this would be something that is displayed to us if we do incorrect input, right? The application doesn't check the contents of the error parameter, which allows us to insert malicious code. So we can then go and put whatever script right after the error portion of this URL, or input it inside of the actual source code for the value that we saw previously right here, right? Inside of the paragraph, you see that it's just basic text, right? Invalid input detected. You would just go ahead inside of that paragraph that opens with this P and closes with this /P, you put your script. So everything that starts with the script and ends with the script, that's basically it, right? And then you just go ahead and put your evil.javascript location, and then it would just launch it ideally. So the vulnerability can be used as per the scenario that's displayed to us here. So this is the full scenario here. So first, as the attacker, we send a link to the victim that contains a malicious payload. So this one's more zoomed in so we can look at this here. So we send a link to the victim that contains a malicious payload. Now, the victim clicks the link and is taken to a vulnerable website. And this is what we would see right here. The link containing the attacker's script is then executed on that vulnerable website. So this guy right here is on the website already, right? And we've poisoned the website. We've injected the website with our stuff, with our JavaScript. So when the user clicks it, the vulnerable website is now executed on that, or the script is executed on the vulnerable website. And when it's executed, it goes back to the victim, and whatever the data that the attacker's script is gathering is actually sent to the attacker. They could steal the victim's cookie, which would allow us to take over the victim's account or anything like that, right? So it's not complicated as far as the flow of the process is concerned. It just requires this piece. This piece is very, very important. The vulnerable website is where all of this kind of is combined and integrated together. If the website is vulnerable, we can inject it with our malicious code. And then if this guy goes over here and just clicks on one of those things that's like a normal thing for him to want to use, what's going to happen is that it's going to execute on the website, and then by executing we get whatever the goal was that we wanted it to get. So the attacker could send links or embed them into an iframe or another website containing a JavaScript payload to potential victims, getting them to execute code on their browser, potentially revealing session or customer information. So how to test for reflected XSS, which was actually one of the vulnerabilities that we saw at the very beginning that somebody had exploited on HackerOne and they got paid $2,500 for it. You have to test every possible point of entry. So it could be parameters in the URL query string, the URL file path, HTTP headers, although it's unlikely, or just modifying the source code as you just saw previously. Once you found some of the data, which is being reflected in the application, the web app, you'll then need to confirm that you can successfully run the JavaScript payload, and the payload will be dependent on where in the application your code is reflected, and we're going to talk about this in a little bit. So where in a URL is a good place to test for XSS on reflected stuff, and that would be in the parameter. And again, the parameter is everything that starts after this equal sign. So you see, or actually after the question mark. When you see a question mark, the first piece that you see is the parameter. And after the equal is the argument for the parameter. Now, the specific argument previously was invalid input detected. So the parameter is error equals, and then the argument for that parameter is invalid input detected, okay? Everything after the question mark is what you are interested in looking at when it comes down to URLs specifically. So you find the question mark inside the URL, and then everything after that question mark is what you would want to pay attention to, and then after the equal sign is where you want to start injecting things, right? So error, parameter, equals, and then after the equal sign is where we want to start injecting things. And then you can even look at the source code to see if you can just modify the source code accordingly. And that's what we did on the last video with the server-side request forgery. We actually did that, and we were able to gain some interesting access to certain parts of a website. So that is all falling under reflected XSS, everything that we just talked about so far. So let's go into stored XSS. In this particular type of XSS, the payload is stored on the web application and it's inside of a database, for example, and then it runs when the other users visit the site or the web page. So it's stored. For example, a blog that allows users to post comments. These types of comments aren't checked for whether they contain JavaScript or filter out any malicious code. So if we now post a comment containing JavaScript, this will be stored in the comment database of that blog. And every other user now is actually visiting the article. They'll have the JavaScript run on their browser. Pretty crazy, right? So they don't even have to click on it, right? It's like the comment, as long as it loads, it'll then run, which is insane. If you really think about it, they don't even have to interact with it. They just have to visit the web page and then it'll run. Crazy to think about. So the attacker, this is the first part, right? So we insert malicious payload into the website's database by, for example, leaving a comment, and inside of that comment there is a specific source code or there's some kind of a link that would inject the script that we want into that website. For every visit to the website, the malicious script is then activated, and then the victim is visiting the site, and as soon as it loads, it finishes loading, it actually loads on their site. The data to the attacker script gathered is sent to them, and then they could steal victim cookies, etc., and just execute on whatever their goals are for their specific attack. But very, very simple, right? It's stored on the database of the website, and then it'll just launch every time that the victim visits that specific web page, and they don't have to interact with it, they don't have to click on it. So this specific type of XSS could redirect users to another site. They could steal user session cookies, perform other actions while while acting as that specific user. So how we can test for this is every possible point of entry, very similar, where the data is stored and then shown back in areas that other users have access to. And it could be comments on a blog, it could be user profile information, it could be website listings. So developers think limiting input values on a client side is good enough for protection. So changing values to something the web application wouldn't be expecting is a good source for discovering stored XSS. For example, the age field that is expecting an integer from a drop-down menu, but instead you manually send the request rather than using the form that allows you to try malicious but it's very interesting. Like it's expecting something small, so it has a drop down, but then you just manually modify that. So once you found some data which is being stored in the web application, you'll then need to confirm that you can successfully run the JavaScript payload. The payload will be dependent on where in the application your code is reflected, and we'll talk about this again in a little bit. So how are stored XSS payloads usually stored on a website? And they are inside of a database. So let's talk about DOM-based XSS. DOM stands for the Document Object Model. It's a programming interface for HTML and XML. XML is kind of just a more advanced version of HTML. It represents the page so that programs can change the document structure, style, and content. The web page, a web page specifically, is just a document, and this document can be either displayed in the browser window or as the HTML source. And this is a diagram of what this looks like. So the document itself, the root element of it is the HTML version, and then inside of the HTML version, you have the header, the title, and then the text that actually connects to it. So all of this is underneath the header. Inside of the header, there's a title. Inside of the title, there's the text, my title, or whatever the title would end up being. Inside of the body element, you have a variety of different attributes could exist, right? So the A attribute, the A element, has the href, or ahref is what I call it. And this ends up being a hyperlink. This is something that we can actually click on. So the ahref is something that is pointing to a link somewhere. And then that specific link always has a text value as well. And so what you'll see on the screen is a link. So let me see if I can actually find one right here. Right here, boom, perfect. So what we see right here is w3.org. But if I actually look at this, so if I inspect this specific element, we'll see that it's actually a href. So, whoops, that's not, oh, come on, buddy. Let me make sure that I can actually zoom in here for you. There we go. So we can see that it's a href, right? So a href, and then it has the actual link, and then the text, which is w3.org. So all we see is the text, but clicking on that text will take us to this specific link. And so this is what we're looking at over here. Now, there's multiple elements that can go inside a body. There's multiple elements that can go inside the header. So this specific h1 tag is just the header, like the headline that you would see. This piece right here is, I think, like a subhead. This would probably be the header. So if we go to this and we inspect this specific piece, we'll see what kind of tag is associated with it. So where is it? It's this piece right here. So if I take this and if I expand it, we can see it's DOM-based. There's no actual header or H tag or anything that's been associated with it. If we go further up, we don't see any of those things either. But we do actually see that there's a font size that's been associated with it, and that's kind of it. And then what is the DOM would be another element right here that we can go ahead and look at, and then that'll bring us over here. And this one, if we go here, let's see, font size 18, that's basically all we see right here. And then the text value itself is just what is the DOM. So there are different versions that we can do this. In this particular case, instead of just putting H1, they actually give it a font size. And so in this case, the element H1 takes whatever attributes are associated with that H1 element, which is usually font size 18, and it's in bold. That's kind of just depends on the styling sheet. I'm digressing a little bit, but you just look at it, right? This is the document. So when you look at the document has a bunch of source code. Various elements of the source code will do different things, okay? And underneath the overall HTML root element, you can have a bunch of different individual sub-elements, and inside of those, you can have all of the other types of elements, and then they could be text, they could be links, etc., etc., etc. So if you want to learn more about this, you can actually visit this website right here, which is through W3, and it just teaches you more about this kind of stuff. And this is a very, very, as you can see, there's no styling sheet associated with it. So if you looked at any of these things, it's more useful to actually kind of, if I clicked on this and then inspected this, we could learn more about this than anything else, because we can come over here And there you go. That's the H1 tag right here. And so the H1 tag has been applied to this. So that's our header. And then this one most likely has the H2 tag, which gives us the subhead. So you see this is an H2 tag. And then it goes further down. And then if there is an H3 tag, which I don't see, so it's a bunch of H2 tags that basically fall under this one H1 tag. So this is kind of what it looks like, right? You can just look at the contents of this page just so you can see what these various HTML elements will resolve to, okay? That's all you need. Now, exploiting this specific XSS vulnerability. So this type of vulnerability is the type where JavaScript execution happens directly in the browser without any new pages being loaded or data being submitted to the backend, to the server. So execution occurs when the website JavaScript code acts on input or user interaction. So the website gets contents from the Windows location hash parameter and then writes that onto the page in the currently being viewed section. The contents of the hash aren't checked for malicious code, which allows us as the attacker to inject JavaScript into that specific portion. So crafted links could be sent to the potential victims, redirecting them to another website or stealing content from the page. So if they click on this, right, that could basically just be something that we've put maliciously, and it looks like a normal link. Right? If you want more information about, X, Y, and Z, click here, and then the person wants more information, they click it, and that specific hyperlink is going to send them somewhere that we would want it. So how we can do this, how we can test for this, can potentially be challenging because it requires you to understand JavaScript to read source code. So this is kind of one of the most challenging ones. You need to look for the parts of the code that access certain variables that an attacker can actually have control over. For example, window location X is a parameter, and you need to be able to notice these types of things that would exist inside of the JavaScript. When you found that, then you'd need to see how they're actually handled and whether the values are ever written to the web page's document or if they're passed to unsafe JavaScript methods, for example, eval for evaluation, right? So what unsafe method is good to look for in source code? It would be potentially eval. So to take from this whole section, the big piece that you can take is, all right, what do you want to look for to try to do this kind of attack? You want to look for eval inside of the source code. And if you can actually find that, so let's go see if we can find eval inside of the source code, which I don't think we can because I think this website is entirely HTML. But let's just look at the source code. So we're going to go, where's view source? I can just right click, do view page source, and we can look at the page source. And if we can find eval, and we can't because it doesn't exist, because even though it's a super basic page, they were not silly enough to include that kind of vulnerability inside of the web page. But that is something that you can potentially look for to pull it off. Now let's move on to blind XSS. This is the portion that was referenced multiple times throughout the contents today. Blind XSS is similar to stored, which we actually have looked at in the case that, the payload gets stored on the website for another user to view. But in this case, we can't actually see the payload working or be able to test it against ourselves first. So this is the piece right here, right? So what we did in server-side request forgery video, which was the last video, was similar. There's actually a version of it which is blind SSRF, blind server-side request forgery. And the whole thing implies that we can't see whether or not it's working. So we have to find other ways to track whether or not it's working. Now, an example would be a website has a contact form where we can message a member of the staff. The message content doesn't get checked for malicious code, which allows us to enter anything that we want. Then they get turned into support tickets, which the staff views on a private web portal. So we don't see that last part of it, right? We don't see this piece right here. We submit it and then it gets sent. And we can't tell whether or not it worked unless we have some kind of other type of tracking. So using the correct payload, we can actually make calls back to our own website, for example, which reveals the staff portal's URL, the staff member's cookies, and even the contents of the portal page that's being viewed. Now we can potentially hijack the staff member session and have access to the private portal. So how do we test for this? We test for blind vulnerabilities. You need to ensure that the payload has a callback, right? So it needs to send to your server or your website or some kind of a reverse shell or some kind of a listener, something. There needs to be something in place that can track whether or not this is actually working. This way we can actually see when it's being executed. A popular tool for this is the XSS Hunter Express. And it's possible to make our own tool in JavaScript. This will automatically capture cookies, URLs, and page contents and more, which is this little tool right here, the XSS Hunter Express. And as many other tools that we have, this is actually available on GitHub. So if you go to github.com/mandatory programmer/XSS Hunter-Express, you will be brought to this page, and then you can go ahead and download it, or you can clone the repository. Of course, there's documentation available that you can review to see how you can use it. There are screenshots available. Very, very cool tool, very, very useful tool. And it's something that you can use when you go on HackerOne and you're trying to see if you find any website or any company that wants you to check for XSS vulnerabilities. You can go ahead and use XSS Hunter to run your tests and see if you can find. So what tool can you use to do this? That would be XSS Hunter Express. And what type of XSS is similar to blind XSS? And that would be stored XSS. And that's pretty much all we got. So let's now do the exercises. So the first one is perfecting the payload exercise. So I'm going to start this machine, and it's going to load while we go ahead and read the contents. I need to minimize this, so while it loads in the background, we're going to read the contents. First, we need to understand what a payload is. And the payload in this context and in very many other contexts is essentially a script, right? It's code that's going to be sent and then it needs to be executed. So in this case, it's no different. It's JavaScript code that we want to execute either on another user's browser or as a proof of concept to demonstrate that a vulnerability actually exists. So the payload could have a lot of different types of intentions. It could be to bring up an alert or to prove that we can execute JavaScript on the website by extracting information from them or from the user session. So how it gets reflected in a target's website will determine the payload that we actually get to use, right? So how it gets reflected will determine what you need to use. To explain this, we're going to actually use this virtual machine that was just launched for us. We're going to execute this specific alert with the string THM that's going to pop up, right? So very, very basic script. It's just an alert. It's going to pop up and it should read THM. If we succeed, it should read THM. So we're presented with the form on level 1. You want to enter your name. Once you've entered your name, it should be presented on a line below, for example, hello, Adam. So in this particular thing, we're just going to do the pop-up, right? That's basically it. So if you view the page source, you'll see that the name is actually reflected in the code. Instead of entering the name, we're instead going to try entering the actual payload. And then when we click the enter button, we should get the pop-up. And then if we looked at the source code, we can see that it says hello, and it has the source code in there, right? So it actually has the script inside of the source code instead of Adam, right? So this has hello Adam. So whatever value you put into it is actually going to be printed, which means it's going to be executed. So you can put the script and then it'll still say hello, whatever the script is inside of the source code, but the pop-up will actually execute on the screen and then we'll see THM executed as the pop-up. So that was one piece. The next one is similar to what we had, except now instead of it actually saying hello Adam in the source code, it's actually on the page, and now it's going to have a separate button for us, right? So we can see that here. So if we look at that, the source code, instead of saying hello Adam, it'll say hello, and then it'll say input value for Adam. Input value being the one that was collected from this, right? So the value for this input is going to be printed on this section, and the source code will read hello, and then it'll give us the input value of that previous form item. So it wouldn't work if we were going to try the previous payload because we can't run it from inside the input tag. So instead, we need to escape the input tag so that it can actually run, and we can do this by using this piece right here. So you see the quote, and then this forward thing, and then inside of the quote forward thing, you then have the script portion, right? So the quote and forward or greater than symbol, whatever, it closes the previous value parameter. So it closes this right here, right? So you see this, right? You see this, and it's the very end of this that you can see right here. So if you do that, you're now putting that into here, so it closes that input value for you. So it assumes that it has something, and then it'll move on to executing the next block of code, which will be this block of code. And so if you do this, now you can see, right? So quote opens up, right? So check it out right here, right? Input value, quote opens up. There's supposed to be some kind of text, and then the quote, and then it closes. And so this is what we have right here. Now it opened up with the quote for us automatically, and we gave it a quote, and then we closed it. So this input value is now complete because it has the open right here, and it closes right there. And then we can move on to the next block of code, which is going to be our actual payload, the script, right? And then that'll give us the response, the pop-up that we want. And then finally, we have another one asking for the name, and the name as previously before. So you do see it right here. So this is now, we have the first input, and then we have another one. And this is now a bigger block of text. This piece right here does not have the option for you to drag it open. And then this one right here actually does. You can see it by this bottom element right here, that piece. That allows you to drag it open and enter like bigger paragraphs and modify paragraphs and things like that. So we have to now escape the text area, and we need to do it a little bit differently from the previous element, because this element right here is not similar to what we had up here. So this one had input, which was the initial parameter that opened it up, and then there was a value inside of it, and then we were closing the value, right? And now inside of this input element, it's already done. So this is why HTML is kind of important. So you see the H2 right here. Every single one of these things has to have its counterpart to close that piece. So div opens, and then we have this / div that closes. You have H2 that opens, and then you have / H2 that closes. We have script right here that opens this portion, and then we have / script that closes to say that this portion is now complete, right? So for input value, what we need to make sure is that it didn't have the open bracket, input, close bracket. It didn't have that. It has input, and then the next piece is the parameter, and that parameter needs an argument, and then it has the close bracket. You see that? So when we know that this type of stuff exists, and that's how text for XML and HTML, that's how source code works, then you get to make sense of this. So we have H2, and it closes with an H2. This one has text area, and it closes with a text area. So what that means is that instead of just doing a quote and a close bracket, we're now going to do the closing text area element, which is what's required for this to close. And then after that, we input our script. So the final piece looks like this: text area open, text area closed, and then we have script alert, etc., etc. And then there's this other text area, that second portion of the text area, that's always going to be there. So the important part is this first piece, which is the first element closing, right? Now we can see that it should technically work. The last portion, I think, should just be like a little glitch, or it should not even give us a glitch. And that should give us our pop-up. And then finally, we have the name into the form. You'll see that reflected on the page. This looks similar to level 1, but upon submitting the page, you'll see that the name gets reflected into some JavaScript code. So this is the source code right here, and it doesn't show us an example screenshot of it, but we have script, document, get element by class name, and then in the 0 index position, which is the very first index position, inner HTML, and that's Atom. So that's the whole piece. So we'll have to escape the existing JavaScript. So now we actually have JavaScript that's going to display the name. So we need to exit it so that we'll be able to run our own code. And so to do this, we need to just do the / and then the semicolon, which will close this script out. And then we put the alert, and then that's it. So we'll see that it will execute the single colon, closes the field specifying the name, which is this guy right here, this piece right here. It closes that, right? Then the semicolon signifies the end of that full command, and then the double / make anything after it a comment rather than executable code. So we have this whole piece, and then inner HTML equals quote, quote, semicolon. So this is now fully done. This entire piece is fully done. And then after that, we have alert, THM, etc. And then anything after that would be considered a comment, which would not be executable. And finally, we'll be able to get our pop-up. And then we have the one as level 1. So it's similar to level 1. And the name also gets reflected in the same. But now if we try this piece, it won't work because you will actually get, I think, sanitized. So the word script gets removed from the payload because now it's stripping it out, right? There's a filter block in place, so stripping it out. So if that's the case, we need to then find a trick around that, right? So now instead of just putting a single script, you're going to do S script crypt. So what it's going to do is it's going to delete that because it'll notice that as an actual word that's been blocked. But then once that's deleted, this piece combines with that piece, and now you have a script that's executed. And then same thing for the closing portion. So those things are to be removed, and then the final payload ends up working like the normal stuff. And then it'll actually run and you'll be able to get it. And then we have this piece where if we look at the source code, it's now being pulled from what looks like an image source. So we still have to close it just like we did previously, but that doesn't seem to work. So let's expect it. So if we look at it, we'll see that this is actually being placed inside of an image source tag inside of the HTML. So obviously that's not going to work if you do that because it does need some kind of image source. So we can see the AND characters right here. So where are they at? Not the AND characters. I'm so silly. You can see these and these two characters that are getting filtered out from the payload, right? So these characters right here, they're being filtered out. This is being filtered out. This is being filtered out. So all of those things are being replaced. So kind of similar to what we can do previously is you can first test out whether or not this actually is going to work by actually putting an image in there. So you would do / images cat, etc., and then putting on load, which is another one of those parameters, one of those functions that exists inside of JavaScript, and then viewing the code, and then we can see that this is what it's going to look like, and on load it should get that. So when we click it, the pop-up with the THM screen, text will actually pop up. There's something called polyglots, and it's a string of text that has escape attributes, tags, and bypass filters. And we have something like this, as you can see right here. There's a bunch of escape characters in here. And so when you look at this, you could have used the below polyglot on all 6 of our levels that we completed, and it would have executed the code successfully because there's a bunch of escape characters in here that allow the JavaScript code to run as normal. So technically, what I could do is I could just use this in every single one of the exercises, and you would be able to execute it properly. But I think what's useful is to actually learn those individual portions, these individual modifications that can be made to learn what it's like to manipulate the various defense mechanisms that exists on a specific server, right, or on specific JavaScript websites. So what we're going to do is we're going to implement all of these things. A lot of them are pretty self-explanatory and easy to understand. So just to make our lives a little bit easier and quicker, because I don't want to repeat everything that I did because I literally read them in as best of a detail as I possibly could. So what we're going to do is going to run the exercise that would get us our 6th. Actually, no, we need to go through all of them to be able to pull it off. So I'm going to do this one, right? Hank, press enter. It says, hello, Ank, confirming XSS payload, and nothing is actually input in there. So the very first one that we need to input is just the normal XSS script that we have right here. So we'll just go here, and then we're going to paste this in here, press enter, and now we get a pop-up that says THM, right? So that actually worked, and there we go. So that was level 1, right? Now we can move on to level 2. Now this one isn't going to work because it's just going to print the script onto the screen right here. So if I go and look at the code itself, right? If I look at the source code right here, boom, right here, we'll move in on this. We'll see hello input value, and then it actually has the script, all of these things. So what we need to do is we need to close the boom, and then we do that one right there. So that's what it will look like. So you do that, press enter. and now we should have the XSS payload, and it didn't pop up. So let me make sure that it actually works, because I really do want it to work. So, oh, I think I did it in the wrong place, sorry. So it needs to be in this place, not the hello portion. So it needs to be in that place. Press enter. There you go. Now we have the pop-up. Excellent. So now we can move on to example number 3. This one right here, if we do Hank, enter, and it says hello Hank, this is the text area portion, right? So if we look at the source code for this again, so inspect the element, go right here, we go right there, and then we should see that it says text area, and then it has that. So we need to put this piece right here, this last piece, closing piece, before we put our script. So it's going to look like this. You do that / text area and then close, and then from there you paste your script, right? And then press enter, and there you go. There's our pop-up. So that's level 3. Level 4, if we go into press Hank, it'll do what? Hello Hank. And now we can look at the inspect element of this to see what this is showing. And it's a span class name. So it says hello span class name Hank, and then it closes it out for us. And so what were the instructions for this one? I forgot that one. So this is on level 4. If we go to level 4, yeah, this is the one where it's actually doing a script execution already for us. So to be able to finalize this one, so if we go over here, payload failed, obviously. So if we do an inspect of this element and we go here, zoom in on this, we can see that there's a span class, etc., these things being executed, and this in the background, I wonder what part of this I should be able to see my JavaScript being executed, because I am very curious to actually find that specific JavaScript that's being executed. And let's see where we can find it. I think it would be under, not under network, it's under sources. Nope, it's not under sources. It should be somewhere. I wonder where it was. But it is something that we have been confirmed to notice that there's a script being executed. It just doesn't tell me at what location I would be able to find the script. I think it would be something that I might have found if I had, you know what, let me just look around for it, because I know that I can find it, because we found it for all the other ones as well. Oh, it's actually right here. It's right below that piece that we had right here. So underneath this, so it's inside the same div, right? So if we open, or as underneath the form, there we go. It's inside the form, inside of the ID content. So that's the piece right there. So ID content, right there, there's a document get elements by class name, and then the name, and then Hank. And if we go into this piece right here, which was where the actual form was, and it says hello Hank, etc. And so from the form, it's pulling that, right? Get elements by class name, and it's pulling all of the data that are inside of this form itself. So this is the piece right here. That's the piece that's being executed. So we need to make sure that this piece right here is being closed out based on the information that we received. So if we actually execute it as such, we do the closing quote, the single quote, we do a closing semicolon, and then we do the alert THM, close that, and then we do another semicolon //. So boom, this is what it will look like right here. Enter, and it'll then execute, and there you go. It now executed the JavaScript code, and we actually have it. And then after that, it closes this back out, right? So there we go. Now we can move to level 5, which is going to again ask us to enter our name, but this is the one that's going to sanitize the full script, right? So if we go and execute it, we should be able to see that this piece right here, look, it removed everything, right? So if I go ahead and inspect for this specific element and we pull it right here, we can see that basically everything from our script was removed, right? The open and close elements of it were still there, but everything else was actually removed because the word script does not exist. So in order for this to work, we need to modify the script in this capacity. We actually put the word script inside of script right here. So you see S script and then crypt, right, like that. And then you got to do the same thing right here between the S's of the script. So just put another script in there like that. You do that, and then you come out, press enter, and then there you go. It executes it for you. and it'll confirm our payload execution. And finally, we have level 6 execution. So we'll go to this one. And this is the one that the image cat should be pulled, right? So there you go. You have the images cat being executed. So if I pull anything in here that's a script, it won't execute because it's going to look at an image source for us, right? So if I go ahead and inspect this image, it'll pull this up right here. And this is what we're seeing, the image source, and then the enter an image path. If we inspect this, we'll get to see that inside of that, there's this other piece that's being input into the form. The name for the payload is actually getting the request for this specific thing. So we see the images cat being requested, and then the actual image is being pulled from that folder, the images folder. So what we need to modify in this is a little bit different from what we saw previously with everything else, because we're not now doing the full-on script command. Now what we're doing is doing the images cat and all of that, but now we need to close it with a close quotation. We put a space, and then we do onload equals alert THM, or, you know, let's do Hello Kitty, because that part really doesn't matter. And we do that, and then we close that, and then we do, I think that's it. That's basically it. Do that, press enter, and we should get the pop-up, and there we go. It says Hello Kitty. So that part doesn't really matter. And there we go. The final execution is now going to be confirmed. Oh, because it's that's so funny. It shouldn't be Hello Kitty. It should actually be THM, because they really want that specific phrase to be confirmed. Otherwise, they won't give us our credit for completing the exercise. So there you go. THM has not been executed successfully. And there is the final flag. That's so funny that like it has to say THM, otherwise you won't get the full XSS flag at the very end of this. Now, what I'm really curious about is using this thing right here, right? So they said we could technically use this for every single one of them, and we should be able to launch the flag or launch the thing. There you go. So that one worked for that. So if we go to the very first one, and we also input it here, same thing, right? I'm using the same thing. It launches. There you go. If I go to the next one, do that, press enter, launches. So it works for every single one, which is what's known as a polyglot. And I know a little bit of JavaScript. I have no idea what a polyglot is. And I could technically have Gemini explain it to us. So let's see. Can you please explain the above polyglot? Let's see what we get from Gemini, because it's very good at explaining complicated things. So in this context is a piece of code that can execute successfully in multiple different contexts or bypass multiple different sanitization filters, often by cleverly closing or manipulating tags. This particular one is designed to trigger an alert THM pop-up in various XSS scenarios. And the overall goal is to do this, right? Detailed breakdown, you have this. I mean, this is so much of a breakdown that it's like a whole thing to be able to learn from here. But one of the key things that I would tell you to do, I'll say this, right? Look at this. We're going to do this just because I love you and I want you to succeed. I'm going to terminate this machine. We're going to zoom in on this mofo. Super, super zoomed in. So there we go. Let's zoom in. And you're going to get to see this right here, just in case you don't have access to TryHackMe. Pause the screen. Have fun typing this out. But it needs to be case sensitive, and all of the different elements of this should be done correctly. So type this out, right? Take this word for word and go ahead to your favorite AI and have it explain it to you. And then you'll learn what a polyglot really is. But to know what it is, you can just know that it's meant to be executed in different environments and still be successful. In this particular case, it's an XSS polyglot. And as you just saw, it will work in every single one of those 6 exercises that we just went through. So very, very useful to know things like this. And I have yet to master anything that's even remotely close to this. So I'm not in any way explaining this or saying this from a high horse or trying to act like I'm better than anybody. I literally would not be able to begin to explain this for you unless I went through a word-for-word reading of what Gemini just gave me. And that's beyond the scope of this video anyways. It's good for you to know that things like this actually do exist, so that you can go ahead and take advantage of them if this is something that you want to specialize in. When you go into further different levels of penetration testing, this might not be a bad thing to specialize in, because cross-site scripting is a really big one. It's one of those really big topics that companies pay for, and there's a lot of forums in different companies' websites that you can mess around with to see what can potentially be done. And if you can execute a basic alert pop-up, then you can technically execute a variety of different types of scripts and technically do malicious things, which means you can get paid from the companies on HackerOne and so on and so forth. So I'm going to stop reading. I'm going to stop beating the dead horse, the proverbial dead horse. And we have the next exercise, which is going to be our blind XSS example. For the purposes of this particular exercise, we need access to the virtual machine, the target machine that's going to be launched, which is what was launched right down here for me. And I also need to start the attack box, which is the internal attack Linux machine that's available through TryHackMe. You can also connect via OpenVPN to the TryHackMe server and then use your own computer and the IP address of your own computer to pull this off. You do need to have Netcat installed on your computer if you're going to exercise this, because we do need to create a Netcat listener on our attack box or on our main computer so that we can get that connection back from the victim machine, that website that we're going to be exploiting. So the whole purpose of this is to essentially combine a few of the tactics that we've learned so far with another tactic, which is to create a reverse listener with Netcat and then establish that connection. So once the virtual machine is launched and the attack box is ready, this is going to be the website that we're going to get access to. We're going to go to the customers tab, we're going to create a new customer profile, and then we're going to go to support tickets and we're going to start creating tickets. Now the first one that we're going to create is just going to say test in the ticket. So this will be ticket number 1, I guess, or this one is ticket ID 3, whatever. So you do test, and then you just want to see what the response of the page is going to be and what the source code is going to show us. Now, in this case, it's a text area, right? So we've already seen the text area element of this. So we know that we need to have this close tag right here so that we can actually execute something with JavaScript after that text area is closed. So that's the first one. We see it. So we see that we can now do another version of this. So we'll do text area test, and then we look at that, and then we can see it right here, right? So you can see that we close the text area right here through the first portion, and then we put test, and it still printed the test for us. So it's not like it's not available. It's just that it printed the test outside of the text area. It's kind of hard to see, or maybe it's on my monitor that it's hard to see. On the recording, it seems to be that it's actually easier to see. So you can see that there's the text area itself, and the word test is printed outside of the confines of the text area. So that means that this actually worked. This piece that we have, that actually worked. So now what we can do is we can try to see if we can run JavaScript inside of that little portion and see if it'll actually execute. And if you do run this piece right here, you should get a pop-up that will give you the alert THM. So what I'm going to do is I'm going to just launch from this portion right here. I'm going to create the payload that will connect to our Netcat listener. And from the Netcat listener, we should be able to get a reverse connection to the web server. And then from there, we should be able to technically get the rest of the data that we need, which is mostly the document cookie. That's the big piece that we're trying to get. We're trying to get the cookie value of the document. And so this is the full payload that we're going to be executing now that we know that we can actually execute JavaScript. So the first portion of this is the text area, right? So this portion closes the text area field. This portion opens an area for us to write JavaScript. And we've already talked about what the fetch command does inside of JavaScript. It makes an HTTP request. Now the URL or IP portion right here that you can see right here, this is going to be the IP address that is assigned to my attack box. And on your own machine, if you have Windows, you can do ipconfig and you would get your IP address. On Linux or Unix, you would do ifconfig, and then you're looking for the interface IP address, which is usually like ENS0 or ENS5 or something like that. And that specific interface value will end up having an IP address assigned to it, and that's the IP address that you want to find. And I'll show you kind of what that looks like in a little bit. So you put the IP address in this particular case. So it could either be the catcher URL, because you could put a URL in there as well, or the IP address that we're going to end up using. And of course, the port number that's followed up after the fact is the port number that we're going to be listening on. So in this case, this is the port number that we're listening on. So it would be whatever the IP is, colon 9001, right? If you use that port number. Then we're trying to pull the query string, which is the victim's cookies, right? So this is, remember, anything after the question mark is a query. It's starting a query. So we're looking for the cookie, and then we're trying to pull that cookie string. We're going to base 64 encode it, and we're going to pull the document cookie, which is all available here. So boom, after you've input the port number and your IP address, you start the parameter, which is the cookie string, equals, you have the closing quote right there, and then with the plus sign, we're going to concatenate the next portion, which is the base 64 encoded version of the document cookie, and then we're just going to close out our script, and that's pretty much it. That closes the actual JavaScript code, and then now we should be able to execute that and get a listener connection through our netcat connection, which would then allow us to see the request that comes through the victim's cookies, and then we'll be able to hopefully get the final answer for this. So it says you may encounter issues when receiving the request using your own VM and the VPN, so it's recommended that you use the attack box. And this is the main reason why I pretty much default to using the attack box instead of using VPN and connecting to my own computer, because there are some times that there are issues that are generated when we do exercises like this one. So I am going to be using the attack box, and that's pretty much the whole thing. That's how the story goes. So from here, the very first thing that I'm going to do is I'm going to open up my attack box machine in a new window so that we can go ahead and just kind of zoom in on it and execute the exercise. So we have the machine right here. It's opened up for us. It's in split screen. I'm going to open up the terminal. The first thing that I want to do is I just want to create this netcat listener, right, in order to be able to pull this off. So I'm going to do netcat NLVP 9001. Now those flags for the NLVP, so it's like, you know, do not resolve for domain names. That's what the N, I believe, stands for. The L would be you're in listening mode. The VP, I think it's for like verbose and assigning a port number. I don't remember the flags, so my apologies. Let's actually just, instead of kind of using that as a scapegoat, let's actually find out what the NLVP flags inside of netcat are. So what are the NLVP flags in netcat? What do they do? Let's see what the explanation for this would be. Should be fairly straightforward. So yeah, N is for numeric only IP addresses, so it doesn't resolve for domain names, right? It doesn't perform any DNS lookups, which is useful. L is in listen mode, which is what I already talked about. V is for verbose, which is what I already talked about. And P is for port, so I was actually right. Okay, great. So I don't feel too bad about this now. So that's what we're going to be doing. So we're going to do that, and then we're assigning port 9001 for our listening port. You can technically assign any port, but for my particular case, I'm more interested in using a port that I'm pretty sure is not currently available. And that's actually the first thing that I should probably do. Is first let's run ifconfig just so we can see what our IP address is. So these things are not the interfaces that we're interested in. Those are the Ethernet interfaces. LO is for loopback or local, which is always going to be 127.0.0.1. So that's not it. ENS5 is the interface. And so the IPv4 address is 10.10.230.254. And then you can also see that in the top right here, 10.10.230.254. I just wanted to do the full exercise so you can see how you can find your IP address. So we're just going to clear the screen. And now we're going to do our listening or our listener using netcat. Boom, press enter. Now it says it's listening on the local machine, right? On the actual local machine, it's listening on port 9001. So that part is all good. Now we can open up our browser and go to this IP or this address right here, this full address. That is the address for the website that is potentially vulnerable, right? So we go there, it's going to give us the customer, there you go, Acme IT support. We're going to click on customers. My login from the last one probably does not exist anymore. So we're going to recreate it, and it's going to be Hank at, let's do THM, a bullshit email address. Password is going to be password. So this is all like almost irrelevant what you enter, because you're just going to end up creating an account. Now, once you're inside your customer dashboard, you're going to click on support tickets. And now we can see a few other things, including create ticket. And so the create subject or the ticket subject is going to be test. The ticket contents is what we're most interested in here, which is going to be the script that we're going to input in there. So in the interest of time, I'm just going to copy this whole piece, which is this full script that we have here. I usually type it out. Should I type it out? I think I'm going to type it out. I just want to like get these things in the bones, right? I want to get them in my fingertips. So we're going to first close out the text area, and we're going to open up a script. We're going to do a fetch command, and we're going to do HTTP / right? And then I'm going to give it the IP address of my attack box, which is the one that we found with ifconfig. We're listening on port 9001. So that fully closes that for us. And now what we're going to do is the question mark cookie equals, and then we're going to close out the quote. So this is what it looks like so far. We've closed out the text area, and we have written the first portion of the script. So it's going to be opening the script. We're going to call on the fetch function, and inside of that, we're going to begin the actual port or the IP address and the port of our listener, right? So this is our netcat listener. That's where it's listening on right now. And then we're going to do the question mark cookie equals, and we just got to make sure that we close that first quote that we have right here. So that's so far so good. So now we're going to do the concatenation with the plus sign, BTOA, so that we can base64 encode. We're going to do document.cookie, and then close the parentheses for that, space, another close parentheses, semicolon, and then we're going to close the script. And then that is the full piece right here. So once we finish that part, we have a space plus space, BTOA, document cookie inside of parentheses. There's another space right there. So if I click one, it's going to move forward. And then the next one is going to be this closing parentheses and then semicolon, and then we close the script entirely. And that's basically it, right? That's the full payload that we have. So now I'm going to click create ticket, and I've created the ticket. So I'm going to go ahead here, and it's already done. It finished the connection, and that was very, very fast. It said we need to wait a minute, but it was really, really fast. So connection received on this port. The cookie value that we wanted to get, right? We made a GET request to get that cookie value is this. So this is the full cookie. It's the base64 encoded version of the cookie. So I'm going to copy that, and then I'm just going to open up CyberChef in my own browser just to make it a little bit faster for us. We're going to paste the base64. What happens is that when it's like a clean piece of encoding, you'll get this magic wand option that will detect what this is right here for you. And so you just press that, and then it'll take it. Now it says staff session, and there you go. That's the cookie that we need for our answer. So JB3, etc., etc., etc. And this one is actually different. So 4AB3 da 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 da. So that's actually different. So that's interesting. So maybe I needed to do the other 3 exercises to be able to pull this off, because the staff session cookie is completely different in this particular case. So I wonder if really it did need to be something else that I had to do, because that's actually very interesting that it's a different value that I got this time. So I will say this, right? So just to make sure you don't have any issues if you're doing this on your own, create the first 2 cookies, or create the first 2 how many did they do? I think they did 2, right? They created 1 ticket and they just did test. And that was the first ticket. Then they did another one where they did the text area test to see if it will leave the text area. So that's 2 cookies, or 2 support tickets, excuse me. So they created 2 support tickets. And then they did one with the alert pop-up. So that's actually 3 support tickets. And then the 4th support ticket was the one that they did with the final payload where they downloaded it. So I wonder if that is the specific order that you need to do this for, because I jumped the gun and as my first support ticket, I did the final payload, and now the value of the session cookie is different from what we have in the answer over here. But you can see that it worked, right? So that's the piece that it's like, okay, well, at least it worked. So that's fine. So I'm okay with that part. But I think it was important for you to do the first portions of this exercise just so you can finalize and get that last support ticket to actually match the answer for you. So again, do 1, just a regular test, and then that's it. The next one will be the closing of the text area, doing tests, so just to see if the test will show up outside of the box. And then the next one is going to be this one where you get the alert of the pop-up, right? The pop-up for the THM. And then, so your 4th support ticket is going to be the ticket that I just created so that you can get that final answer, which ends up being the base 64 encoded cookie that you can just then go to CyberChef for and you can decode it. So assuming that you just don't skip to the very end like I just did, I think you should be fine, and I think you should be able to get that final answer from that practical exercise. And then that's pretty much it. Like everything up until that point was just reading through the lecture materials and then making sure that you understand what these various different types of cross-site scripting attacks are. And assuming you understand that, and assuming you got all that, you can do the perfecting payload, which was kind of like a nice test to see the different types of payloads we can run to get that pop-up to show up. And remember, you have to put THM in the payload so that you can get your final flag. You can't put Hello Kitty like I did, which didn't give us the final flag. So you have to do exactly the one that they want you to do. And then the final one was the blind XSS, which just makes sure that you actually do all of the first 4 tickets, I think, right? Again, I keep you losing count. So you did 1 ticket, then you did 2 tickets, and then you did the 3rd ticket, the 4th ticket. So you do 3 tickets first, and then the 4th ticket will end up being the one that you do the netcat listener for, and then you do this complex payload where you actually have a reverse connection to your netcat, and then it'll retrieve the cookie value for you. And then from there, you're off to the races. You can use CyberChef to base 64 decode that value, and then you'll be able to get the answer. Ideally, it will be the actual answer, because the answer that I got previously when I first ran through this room was not the answer that we just got right here. Very, very different session cookie. But I think it's because, I just think it's because I jumped the gun and I kind of just went to the very, very end and I did the last exercise. But that was pretty much it. I loved this specific exercise. Anytime that I repeat these types of rooms, I get more ingrained, like the data rests in my mind a little bit better, or a lot better, I should say, and I just understand the content so much more. So if it's your first time going through it and you don't get it, don't fret, don't worry about it, because if you go through it again after you've completed it once, go through some other stuff and then come back to this and then go through it again, it'll just click better. You'll understand it better. And every single person that has tried it like that always comes back and they're like, yeah, I understand it so much better now. So I do recommend you doing this more than once. Don't just do it one time, especially if you don't have a background in HTML or XML or JavaScript or any of those things, because it's your very first introduction to it. And so it would be normal if on your first introduction you didn't understand everything that was going on and you just need some more practice and similar exposure to it. So be patient with yourself, be kind to yourself, try it more than once, and I promise you'll get a better understanding of it. And with that being said, we are done with this official room. One final word from Hackaholics Anonymous, and we'll wrap it up. If you found value in this video and you would like to get more videos like this one on Junior PenTester or on PenTest Plus or anything else, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. Make sure you drop a comment in the comment section if you just want to say hi, or if you have any questions about what we went through, because it was a little bit complicated what we went through. But I think if you actually follow the instructions letter by letter, I think you should be perfectly fine. We have a bunch of content that's already on the channel. There's a bunch of content that's in line to come out, including the CompTIA PenTest Plus training series. This specific video I think is going to go down mainly because of the fact that there are a lot of people that are talking smack to me in the comment section, and they are nitpicking on this particular video because when I made it, I was not as well versed in system administration on Linux as I am today, and so I made certain mistakes in my lecture, and people are coming for me in the comment section, and it's disheartening because people can be very, very mean in the comments, as I'm sure you already know, in social media and in the internet. This one, however, see, that's the thing, that's the other thing, that's like this video and this series of playlists, the Linux Plus playlist, has been so instrumental for people passing their Linux Plus examination. And so there was literally a 4-month difference between these two playlists. This one was 10 months ago, this one was 6 months ago. People have used this playlist to pass their Linux Plus examination. This one apparently was not the best version of the video that I could have made, and people are talking smack to me. So it's all the people who are talking smack clearly did not go watch the Linux Plus playlist, which is, I get it, it's fine. So for the most part, it's a shorter video. It's a 2-hour video. The Linux Plus playlist is over, I think, 20 hours of content. There's a lot of content on that playlist, but that's why it's like so comprehensive, and a lot of people use it to actually study for their examination, and they learn mastery of Linux through it. So anyways, I think the shorter one, I think, is going to end up going away. The rest of them are going to stay. We do have the PenTest Plus playlist that's available to you, and it's being updated every Friday. Network Plus is already done. Python for Hackaholics Anonymous is a members-only playlist that's for the Hackaholics Anonymous members. Security Plus is already done. Linux Plus is already done. CySec 101 is already done. We also have the SOC Level 1, SOC Level 2, and Security Engineering playlists that are all already done. Members-only videos that are available here, so all of those things. And the PenTest Plus stuff, members get weeks in advance. So that's another one of those things that is like a really, really big benefit for being a Hackaholics Anonymous member. But apart from that, just make sure that you like, subscribe, and turn on the notification bell. Drop a comment in the comment section if you have any questions. And that's pretty much it. So let's talk real quick about Hackaholics Anonymous, and it will be done. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section on the channel. And that is it for today. So boy, Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I'll see you in the next video later.